The SHAKTI microprocessor is designed, developed, verified and prototyped at RACE Lab, IIT Madras. SHAKTI is a Make in India effort funded by Ministry of Electronics and Information Technology, Government of India. SHAKTI is based on the open source RISC-V instruction set architecture. The 64-bit SHAKTI C-class chip seen here is fabricated using 22 nanometer FinFET technology at Intel Fab, Oregon, USA. SHAKTI is designed to work at extremely low power conditions, matching the compute needs of the emerging digital India. SHAKTI matches power, performance and area parameters of contemporary microprocessors. In addition to the CPU, the chip houses peripheral interfaces including UART, I2C, Quad-SPI, JTAG and DMA, all developed indigenously at IIT Madras. Post-fabrication, the SHAKTI chip is mounted on the indigenously developed motherboard seen here. The SHAKTI team at IIT Madras has successfully booted the Linux operating system on the chip. Some moments of SHAKTI Linux boot up. Booting Linux is the crucial milestone in processor bring up. Close to 70 million machine instructions execute before the Linux prompt shows up. Watch it happening here on the SHAKTI chip. SHAKTI displays the Linux prompt for the first time. We are now logging in as root. Watch the Linux commands being executed.
Hi, I am Rahul. I am one of the design architects of the processor we are developing here. In achieving our targets to develop state-of-the-art process, it is important for us to make some choices like the tools which we are using or the building blocks which we are going to use to build our process. We chose BlueSpec as our hardware description language, which gave us a higher abstraction than the current hardware description languages that existed, and it also helped us in increasing our productivity. And next is we need to choose the ISA. ISA is the backbone of the process and also the software stack that runs on it. So after evaluating several ISA platforms, we chose the RISC-V ISA. It's simple, elegant, and also most importantly, it's open sourced. So we started off building a simple 5-stage pipeline processor, and in order to build optimized building blocks into the 5-stage pipeline processor, we started researching through several leading conference papers and standard textbooks, and aggregating all these building blocks like branch predictors, parameterized caches and MMU into the C-class processor, which we call the 5-stage pipeline processor. We made our processor complete, and when we are actually planning to put our code open sourced, we need to also keep in mind that it should be user friendly and also tweakable. So we made a conscious effort to make most of our code totally modularized and also parameterizable. So anyone with different backgrounds can edit it and contribute to the SHAKTI or use it for themselves. And we also developed several peripheral interconnects and SoC components like Quad-SPI, I2C, and interconnects like Axibus in-house, and which is also open sourced. We also developed random and directed test cases in-house. We made ourselves self-sufficient with the test cases we developed and our verification environment. And after simulating our process to the full, we need to move on to FPGAs. So having been emulated our process on 50 megahertz, we need to next move on to a silicon chip. So there came the opportunity to collaborate with an Intel and make a 22 nanometer chip.
Hope you enjoyed watching the video of the SHAKTI team's eventful journey of our first successful silicon tape-out. We heartily welcome further collaborations with academia and industry. Feel free to reach us out at the link provided in the description. Jai Hind.